Hello and welcome to SudoKanard. In this video, I'll be solving a classic Sudoku which was created by Lucy Audrin and which was published on the Cracking the Cryptic fan server on Discord, and it was put to the test. And I've already solved this puzzle, but I've seen that some people have struggled with it, some even bifurcated, while I could solve it using only logic, so I thought I would make a video to show how it can be solved by logic. Well, provided I can repeat what I did earlier. So let's start. First 1, 2 and 1, 2. Put a 1, 2 pair in those cells. 4, 4 and 4. And there's a 4 here. What next? 8 here. 2 here. 8 in one of those cells. 1 here. 7 in one of those cells. 7 here. 5, 9 pair. There's a 9 in one of those cells. 8 in one of those. 2 goes here. That's the only place in the column for the 2. Those cells now must there's a 1 here and a 4, 6 pair. This is 3 or 5, that's 3 or 7, 3, 5 or 7. 1 in one of those cells and in one of those. So that's the remaining ones. And here 3, 5, 9 and 6. 6 is in one of those cells. 8 in this column. 8 can only go here. This is 6 or 7. 7 or 9, 6 or 9. So there's something going on with those digits. This 4 puts a 4 in one of those cells. So now there's interaction between all those 4s. Next we have a 4 in one of those cells. Here we need a 3 and a 5, and they're not in this cell, so they're making a pair in those cells. And this is 6, 7 or 9. This is 6 or 7, 6, 7 or 9. That's not a 5. That's 3, 6 or 9. Well, what next? This is becoming a little harder. 7 and 9 are not here. We need 4, 5 or 8. This is 4 or 5, and it's not a 4 actually. So that's a naked single. That's a 5. This is 4 or 8. That's 4, 7 or 9. This is also 4, 7 or 9. There's an 8 in one of those cells. This 4 makes this not a 4. We have 3 and 4 in those cells. 3, 4 with a 7 or 9. This digit can only be 3, 7 or 9. We need 6 and 8 somewhere on this row. 8 can't go here, so 8 has to go there. What do we need next? Well, there's nothing really jumping. This is 3, 6 or 7. Where does 2 go in this column? Not here, not here. It could be not here, it could be here or there. Well, 2 in this row goes here or there. And here or there. There's a 5 in one of those cells. So there's a 5 here. And 1 in those cells. There are still 4 choices for this cell. This is not a 6, so it has to be 3, 4, or 7. On this row, we still need 6 and 8. 6 could go, well, in any one of those cells, actually. That's not a 3 or a 5, so that's a naked single. 3, 5, 9. Yes, this is a 6. And 3, 5, 9 in the other cells. About this row, we still need 1, 2, 4, and 8. So this is 1 or 4. This is 1, 2, or 8. This is 2 or 8. Well, that's a lot of pencil marks, definitely. What is still required in here? 4 is in one of those cells, and there's one of 3 and 5. I don't see which one. Still some work to do, definitely. On this row, we need a 3, 3, 4, 6, 7, 8. 3, 4, 3, 4, 6, 7, 8. Oh. Looking for more restrictions. Not easy. As a matter of fact, I have a... Oh, there's a 9 in one of those cells. So this is not a 9. Now we have a 6-7 pair, and this is a 9. So this is not a 9. Okay. With this 9 and this 9, we place a 9 here, making this a 2, making this an 8, making this a 1. No, sorry, that's a 2. The pencil mark was 2 in one of those cells. Now this 8 makes this a 4, this a 1, and this a 1. 7-9 pair, that's an 8. Six, 7, or 9 in this cell. And let's ponder all those findings. No 8 in here. In this column, 8 has to go there, which was also given by this 8. This is 3, 6, or 7. Well, that was some sort of breakthrough, but it's not finished. This is 3, 6, or 7. There's a 4 in one of those cells. Oh, this 8 also resolves this. That's an 8 in this cell. We need 3, 6, and 7 in those cells. There's a 9 in one of those. Yes. That's not a 6, so this is 3, 5, or 7. And now that's the final breakthrough. Let's have a look at those cells and those cells. And we have what is called a skyscraper, or some people also call this a finned X-wing. What happens in this situation is that in some row or column, you have only 2 places for some digit. 2 places, sorry. 7 can only go in here and there. And in some other column, you have almost 2 positions, meaning you have 1 position corresponding to one of those positions, so a parallel position to this one. And instead of just having this cell, which would be the case in a regular X-wing, you have several or maybe an offset position compared to this one. And what happens is that it's almost like an X-wing, meaning that if 7 is in here, then it's not here and it has to be there. And if 7 is not here, then it has to go there. And in both cases, you have 7 either here or there, meaning that 7 can't be in this cell. 7 in this cell would remove 7 from here, and you would have 7 in both cells here, which would break the puzzle. So this removes 7 from the options of this cell. And that's a nice technique, something that's not that easy to spot. you need to practice classic Sudoku a lot. And I think it's useful to spot those, to practice classic Sudoku on apps, on computer-generated puzzles. So anyway, let's remove 7 from this cell, and from that point on, the puzzle should basically collapse. That's a 6, that's a 7, that's not a 7, that's not a 6, that's not a 4, that's a 3, that's not a 3, that's not a 7, this is not a 3, this is not a 3, it's not a 6, not a 7, not a 7, that's a 3, that's a 6, 5, 3, 9, 5, that's a 5, that's a 7, that's a 3, not a 6, not a 3, not a 7, this one is a 3, that's a 4, then we have a 4 in here, and on this column this can only be a 5. And we also get, I think, a 6 in this cell. That's a 3, not a 3, not a 5 either. That's a 3. This is a 7. That's a 5. Now we get this 7, this 9, this 7, this 9, and the solve is over. So that's really a nice puzzle. It can be confusing if you're not trained in spotting those really classic configurations, such as skyscraper, or I don't quite remember the other ones. But that's really a puzzle that doesn't require any bifurcating at all. So thanks, Lucy, for this puzzle. Thanks for watching this video, and see you soon on SudoKanard.